Today we're going to cover the exponent rules. There are 3 of them. We are going to do 2 out of the 3 today. So the first one is going to be the product rule. Now I want you to write down product rule, but I want you to then skip maybe 4 lines, because we're going to do some examples first, and I want you to try to see if you can recognize what that rule is going to be. So we have examples. A to the 4th power times a to the 2nd power. Before we can figure out what the rule is, let's expand this. Let's expand like we learned in our lesson on Monday. So I'm going to take a to the 4th. That means there are 4 a's. 1, 2, 3, 4. And then I have 2 a's here times 1, 2. How many a's do we have all together? That would be a to the 1, 2, 3, 4, 5, 6. A to the 6th power. Let's try another one. 7 to the 3rd power times 7. Now, what do we know that exponent to be? If it's not written there, it's always understood to be a 1. So there are 3 7s. 1, 2, 3. 3 7s, and this one, there is 1. So altogether there are 1, 2, 3, 4 7s. Remember, keep that base. You are not multiplying the 7s. The base stays the same. If I have c to the 6th power times c to the 3rd power, that's 1, 2, 3, 4, 5, 6 of those, and then 3 more. 1, 2, 3. How many do I have all together? That would be 6 to the 9th power. So at this point, I think you must be seeing a pattern. So what is our product rule? Our product rule is when multiplying by the same base, you add the exponents. Okay, but the key is it has to be the same base. Okay, so we added 4 a's and 2 a's, so 4 plus 2 would give me 6. 7, there's 3 7s here, and there's 1 here. There's 4 all together. There are 6 C's and 3 C's. Adding them all up, there are 9 C's. Okay, I'm going to do a few more examples with you, and then we'll go to the next rule. So if we have d to the negative 3 times d to the negative 2. Okay, it's the same base. Now I'm not going to bother to expand these out because I know the rule now. I know that if I have the same base, I'm going to add those exponents. So negative 3, and I'm going to write it out, negative 3 plus negative 2 is going to give me negative 5. Now you can never have a negative exponent, so we learned this the other day as well. We need to flip this, so if this is a 1, underneath it, we're flipping it, and it's going to be 1 over d to the positive 5th. You will never, ever, ever have to operate with negative integers. All right, how about this one? A to the 4th times a to the negative 6 times a to the negative 3. Now just add the exponents. So I'm saying 4 plus negative 6 plus negative 3. 4 plus negative 6 would be negative 2. Negative 2 plus negative 3 would give you a to the negative 5. Again, it becomes 1 over a to the 5th. Okay, let's try one that's they're going to get a little more detailed as we go along. So we're going to do 3x to the 4th times 6x to the 9th times 2x to the negative 10. All right, so the first thing we do is recognize that the base is the same. The base is the same. Okay, x is the same that has those exponents. The coefficients are different, but we're not raising those coefficients to a power. We are only multiplying those x's, base x, to the powers. So you're just going to multiply those coefficients. So we have 6 times 2, which is 12, times 3, which is 36. Now we are going to add our exponents. So it would be 4 plus 9 plus negative 10. So 4 plus 9 is 13. And you're adding a negative 10. So negative, this is 13, plus negative 10 is going to give you a positive 3. It's only with the base of x. Okay, it has nothing to do with those coefficients. These coefficients we would just multiply on their own. They do not have the exponent attached to them. It's only attached to the variable x. All right, let's try this one. W to the 5th, y to the 5th, times w to the 9th, and y to the 7th. All right, I'm going to look at my w's first. There are my w's. Multiplying that same base, I would add the exponents. So I would have w to the 14th, because it would be 5 plus 9. And then now I'm going to look at those y's. I'll circle those. Okay, so my y base has a 5 and 7, so that would be y to the 12th. All right, so let's do negative 3x to the 4th power times negative 3x to the negative 12th power. Now we talked about this with the negative signs and parentheses. Everything that's in the parentheses is multiplied by itself. So I could rewrite that as negative 3x times negative 3x times negative 3x times negative 3x 4 times. Okay? The whole term inside the parentheses is raised to that power. The whole term. So now this is going to stay negative 3x, and we're going to take 4 plus negative 12, and we're going to get negative 8. So the whole thing raised to the power is negative 8. We cannot have a negative exponent, so it would be 1 over 3x negative 3x to the positive 8th power. All right, and one more. We're going to do 4/3 raised to the negative 3rd power times 4/3 raised to the negative 7th power. Now we worked on fractions on our last assignment, and those with negative exponents as well. So if we take and keep our base is 4/3, and it has to stay in parentheses so that we know that that exponent belongs to both the numerator and the denominator. Negative 3 plus negative 7 is negative 10. Negative 3 plus negative 7 is negative 10. It's negative. We cannot have a negative exponent, so we need to flip to the reciprocal. Flip that fraction to its reciprocal, and then that exponent becomes positive. Okay, I'm going to do this video in 2 parts. So there is your first part, and now I'm going to do your second part for you.